And depending on the enzyme, the E prime 0V is going to be different. Just like the E prime 0V of Fe3 plus Fe2 plus was different in that table, 6 different ways. I could show you 6 different FAD enzymes, and the E prime 0V would be different. There's one number in the table. You can find it in here. Here. We don't have any other ones, but you know this. Notice that there's a little star here. Star. This is the value for free FAD. FAD bound to a specific flavoprotein, right? Some enzyme in the cell that uses FAD, but also binds other substrates, right? Like succinate dehydrogenase, an important enzyme that we will study, has a different E prime 0V that depends on its protein environment, right? So this little asterisk here, turns out to be very important for understanding, for cluing us in about how FAD works, different from how NAD works. Okay. Of course, there are pathways in cells to make FAD and NAD. Right? We don't talk about them in this class. They are what we could think of as something called secondary metabolism. We're only talking about primary metabolism. We're talking about like the big guns here, like glycolysis, TCA cycle, some aspects of nitrogen, like urea cycle, like the big names. Right? But underneath that, you have all your hard-working army of enzymes that are doing things like providing NAD and FAD so that the big name pathways have them to use. Right? FAD is a big complex, it's a huge molecule. I mean, imagine what the pathway is like to make it in cells, what the starting material is. What's the starting material going to be? Like bicarbonate and ammonia or something? Right? I mean, what's the cell growing on? Glucose? There's nothing that looks like glucose in here. I mean, this is going to be a huge pathway to make this thing. Right? Costing a lot of energy. So this can help to keep in mind the fact that we've got a lot of this stuff is going on in the background, and while we're not talking about it, we know it must be there. Right? Questions? Yeah.
Maybe the FAD, once it's made, it's generally a status. You don't just keep producing it and recycling it.
Yeah. Yeah. It stays bound to an enzyme, and it probably has the same lifetime as the enzyme itself does. Yeah.
You called the semiquinone an intermediate. Would you call FADH2 in its fully reduced form also call that an intermediate?
I don't know if I want to call the semiquinone intermediate. Did I say that?
You did.
Okay. No. Why don't we back off on that?
Okay.
I like to think of an intermediate as something like an isolated study, and I'm not sure. While we know that exists and it goes through that, I'm not sure how isolable it is. So you could say it's a short-lived intermediate. It's better than that intermediate they talked about in the Kaiman mechanism. That's definitely not an intermediate. Okay, very good. So we're caught up, and we will get into glycolysis on Friday.